In this video, I'm going to share some interesting behavior that I observed when playing around with the PEFT model as I've been exploring base model versus LoRa and Dora fine-tuned model behavior. I'm going to use the A100 instance because I need around 55 gigabytes of system RAM or so because I'm going to be loading multiple models. And let's see, I think I actually have a bunch of extra stuff here that I don't need, so I'm going to remove this, and I think this should be good enough. And the model that I'm going to load in is one of the checkpoints from the LoRa Learns Less and Forgets Less paper, and that uses the Llama 2 base model. So I need to load in my Hugging Face token since I need to access the Llama model. So here is my code for loading the base model. It uses the Llama 2 7 billion HF model, and I'm going to put this on the CPU. So that should take a minute or so to load. Okay, so now we have our base model loaded, and if we look at system RAM, we are at 29 gigabytes. Okay, so let's take a quick look at the base model. Oops, base model. And the key thing is that there are 32 layers. We have a self-attention module, and then we have an MLP module and some other things as well. But these are the main layers that I'm going to look at. And inside the self-attention, we have QKV and the output layer, matrix, and then for the MLP, we have the up-down and the gate layer. All right, cool. So that's the base model. What I'm going to do is I'm going to make a copy of the base model because I want to analyze the differences between pre and post merging models. So we're going to make a copy of this. And if we look at our system RAM, we are now at about 55 gigabytes, which is why I couldn't use the L4 instance because that would crash out. Okay, cool. So that's the base model. Now I'm going to load the LoRa adapters using PeftModel from pre-trained. The model is going to be base model, and the model ID I'm going to copy over. And then we're going to do to CPU. And if we look at the model to merge, we can see it has the LoRa layers that are not yet merged, and yeah, everything else is, similar to the Llama architecture. Okay, cool. So we're not going to look into that too much detail. Next thing we're going to do is we're going to merge the model. So we're going to say model to merge, and unload. And looking at our RAM, we're now at 56 gigabytes, and this will probably increase it a little bit as well. Okay, so what I want to highlight, and this is something that I didn't realize as I was comparing my base model to my LoRa fine-tuned model in terms of behavior, and I was looking at, different differences in the weight matrices, is that this base model up here, which we loaded, because we passed it to PeftModel from pre-trained, this base model has now changed. And to illustrate that, what I'm going to do is first I'm going to print out some weights from the QProj layer. So here's the base model. So negative 0.02, 0283, etc. And then we're going to print out base model copy. And if we look at base model copy, which was the copy that we made before we loaded the model to merge and before we did model merge and unload, if we look at the base model copy, we can see at a glance that the QProj weight matrix is actually different. So base model and base model copy are different. So that's one thing I wanted to highlight. And then if we look at merged model, actually let me just copy this. If we look at our merged model, it actually contains the same weights as our base model. So how I interpret this is that our base model has actually changed. It now contains the merged weights from our LoRa adapters equal to the merged model. So this was just one layer and one matrix that we're looking at. So I wanted to be a little more thorough. And so I'm going to basically look through all the layers and matrices. So we're going to do 4-layer index in range 32. We're going to print out layer. And then for component in the 4 layers or 4 components that are available to us in the self-attention module. All right, so for each component, I'm going to call this W0. So this is our pre-trained. So base model, model, layers, layer index, and from self-attention, give me the component in question, and then give me the weight. So I'm going to do that for the base model, and then I'm going to take this, and we're going to say fine-tune, and this is going to be merged model. And then we're going to say if not, and let's see, maybe this is why I imported torch, so let's do that. So if not, torch all close W0 WFT, and I just use these R tolerances, or the tolerances that I got from Claude. So, you know, maybe there's better ones we could use. And if it's so, if these are not equal, then I want to print out. Let's do tab the component, and I'll add a note here that will print if matrices are not equal. All right, so I'm looping through each of the 32 layers, and then I'm looping through each of the 4 components in the self-attention module. I'm getting their weight for the base model and for the merged model, and if it's not close, if they're not equal, then I'm going to print it out. So if I run this, I should see that my layer index is being printed, but none of the components are being printed because the base model and the merged model are equal. Okay, so that's that piece. And then let's delete this. So I did that for self-attention. Now I'm going to do it for MLP layers. So we have up, down, and gate. So I can actually keep this. Up, down, gate. And instead of self-attention, this is MLP, and this is MLP. I think everything else can be the same. So I should see the same behavior. I see the layer index being printed, but I do not see any of the components being printed. And I don't know why it's so terribly slow today, but that's how it is. And if we look at system RAM right now, we're at 57 gigabytes, which confirms that we can't use the L4 instance. Cool. All right, so I'm going to delete that. And then I'm going to wrap these in a function. Let's just call it diffs. And I'm going to say model1, model2. And first we're going to do different self-attention matrices. I'm going to grab this. And this is not a capital P. And instead of base model, we're going to have model 1. And instead of merged model, we're going to have model 2. And I'm just going to call this W1, W2, and this is, let's see, like that. And then I'm going to do the same thing for MLP. Whoa, where did that come from? W1. Okay, so this is W1, W2. This is model 1, model 2, and this is W1, W2. Okay. And this needs to be bumped in. Okay, is everyone happy? I think so. Cool. So now if I run this and I give it the same base model and merged model, it should print out no components. So it should just print out the layer index because these two models are the same. Okay, great. So a couple more checks that I want to do. Let's see this. So we're going to do diffs, and I want to do base model and base model copy. So if this works, yes. So it shows now that for every layer in the in the model inside the self-attention, all 4 projection layers matrices are different between the base model and base model copy. So we can see all 4 are being printed out, and then we should see the same behavior for MLP, except now we see the up, down, and gate proj layer components being printed out for every single layer because they are different. And my goodness, I don't know why my browser is so slow. Okay, and it goes down to layer 31. Cool. One more thing that I wanted to show, because I was looking at the documentation and it said, if I look at PeftModel, it has a note that, let's see, note that the past model may be modified in place. I think that's related to the behavior that I'm seeing. And then I also saw this get base model function. So I'm going to give that a try. So if we look at, let's do it up here. I'm going to say model to merge, get base model. So I would expect this to have the same weight matrix as our base model copy. But if it repeats what I saw, yeah, get base model actually shows the altered base model matrix, which is the same as the merged models matrix. And so let me grab this. And let's do diffs between base model copy and model to merge dot get base model. And we'll see that they are different. So not behavior that I would expect, and I'm not sure what dictates whether or not the base model gets modified in place. Maybe there's something in the adapter config JSON that dictates that, but I don't know. And just looking through here, all the MLP layers are different as well. So get base model does not, in fact, get the base model that you started with. It gives the in-place modified base model, at least for this situation that I'm working with. Maybe there's an argument in pre-trained. So if I go back and look at from pre-trained, yeah, maybe there's something in the peft config that dictates this. I'm not sure. But anyways, yeah, this was a kind of TIL, Today I Learned video. It's a new type of video that I'm doing for some of these smaller experiments and learnings that I'm coming across. So yeah, if you have any ideas on why this behavior is being exhibited, why is the base model not the same after being merged, and if it's something about how PEFT works and if this is expected behavior or anything like that, please comment below. The only reason I can think of having this behavior as desirable is memory usage. So, at this point, I have, 57 gigabytes. Loading the base model was like 29 gigabytes or so, 28 gigabytes. So the only reason I can think of that this base model would be altered is for memory purposes, but I didn't see my memory going down. It stayed at 56, 57, 58 gigabytes. So that doesn't really make sense that would be the case. So yeah, hoping to do some more of these videos that are shorter and come across some of these curious behaviors that I'm learning about. Awesome. Thank you.